Picking numbers is an incredibly useful strategy, especially if you're the kind of person who does not actively enjoy doing algebra. Though I don't know if there are that many people who actively enjoy doing algebra. All right, so this strategy is particularly applicable when you're dealing with questions that have variables in the question stem and variables in the answers. For instance, a question like this. So take a look at it. I know it looks scary now, but by the end of this lesson, you will have a methodical way to attack a problem like this. So just to point out, right, we have a bunch of variables in the question. We got x, we got y, we got z, and then in these answer options here, we have a bunch of x's and y's and z's. So before we do a problem like this, let's start out with an easier version of it. A machine produces j widgets every k days. How many widgets will the machine produce after m weeks? And then again, I have my answer options, which have variables in them. And we're going to walk through this step by step. So step one is pick your own smart numbers. What do I mean by smart numbers? Well, we'll talk about that in a little bit. Some numbers are better to pick than others. But for now, we'll just say pick any number you want. Let's say that j equals 10, k equals 2, and m equals 3. So from now on in the problem, these are concrete. The machine produces 10 widgets every 2 days. So how many widgets will the machine produce in 3 weeks? Step 2 is to solve the problem so that you get a target answer. Well, I'm just going to solve this problem as if these numbers were in it. So the machine produces 10 widgets every 2 days. I might do some mental math and say, okay, well, that's 5 widgets per day. Per 1 day. So how many widgets will it produce in 3 weeks? Well, in 1 week there are 7 days. In 3 weeks there are 21 days. So I'm going to multiply 5 by 21. 21 times 5 gives me 105. So 105 is my target answer. And that's important. And now that I have my target answer of 105, step 3 is to plug the chosen numbers, that's the numbers I chose right up here, plug those into the answer options and see which one spits out the correct answer. So now I want to plug these random numbers that I just chose into the answer options, and whichever answer option gives me my target answer of 105 is the correct one. Okay, so let's get to work. J times K times M. 10 times 2 times 3. Got 10 times 2 times 3. That looks like 20 times 3, which is 60. Nope, that's not 105. Okay, 7 times K looks like 14. Divided by J times M, 10 times 3, 30. Well, I don't even really need to do the math there. I can tell that's not going to be 105. So A and B are both out. How about 7 times J, 70, divided by K times M, 6. Again, feel free to check that in your calculator. It's nowhere near 105. And then we got K, which is 2 divided by 7 times J times M. Now that's a big number. 7 times 10 times 3. 2 over a huge number is not 105. And then I'm left with this one. 7 times J times M over K. So I got 7 times 10 times 3 over 2. What does that equal? 70 times 3 is 210. Again, feel free to check this on your calculator. Divided by 2 is 105. Well, would you look at that? Answer option E magically produced the target answer. And I know what you're thinking. You're probably thinking like, well, why does this work? How does this work? How is it allowed? The idea behind it is that because the problem is giving you generic values, that is variables, right? If I say X apples, I'm not specifying how many apples I have. It should work with any numbers that you choose. So you can just choose your own numbers, as long as, and this is important, as it conforms to listed restrictions. And we're going to see this in a little bit. But if the problem says that, x has to be greater than 2, then you got to pick a number for x that's greater than 2. But before we get too excited, let's talk about a caveat here. So we'll go back to this question, right? The widgets, the days, the machine, the weeks. But instead of picking numbers like 10, 2, and 3, let's say that I had picked, 1, 1, and 1. I'm just not feeling particularly creative, and I just choose 1. Well, if I plug these numbers in, watch what happens. So I plug it in for B, then 7 times 1 divided by 1 is 7. If I plug it in for C, then it's 7 times 1 divided by 1, also 7. And then if I plug it in for the variables in E, then it's 7 times 1 times 1 divided by 1, 7. So I have 3 correct answers, and I don't know which one is the correct answer. To avoid this situation, you want to pick smart numbers. Now, I referenced this before. Let's talk about that. What are smart numbers? Well, for one thing, not 0 or 1. As we just saw, right? When you plug in 1 to a bunch of variables, it doesn't change anything. It all stays the same. And when you plug in 0, everything goes to 0. So 0 or 1 are absolutely numbers you do not want to pick for this. Along with that, you generally don't want to pick numbers that already appear in the answers. And the reason for that is if I have an answer option, for instance, like 7 over x, and I pick 7 for x, well, then this is just going to become 1. And then we have the same problem as we do up here. Finally, and this is pretty optional, but if you want to try it, I would recommend it. Keep your numbers realistic to the context of the problem. So that means that if you're talking about someone's salary, maybe don't have them earn $2 a year. The reason for this is it acts as kind of a last check for you. If you pick realistic numbers, then you should expect your answers to be realistic. So if you come up with unrealistic answers, then it kind of alerts you that you've done something wrong. And then finally, even if you follow these guidelines, you pick smart numbers, and you still end up with duplicate answers, it happens sometimes. You just want to tweak your numbers a little bit, right? It's very, very rare, but it does happen. Let's try that difficult problem we saw at the very beginning of the lesson. So go ahead and put your video on pause right now, give this a shot on your own, and then we'll talk about it together. All right, here goes. A salesperson earns a 2.5% commission on the first X dollars of sales, a 5% commission on the following Y dollars of sales, and a 7% commission on all sales thereafter. If the salesperson made a total of Z dollars in sales, where Z is greater than X plus Y, how much did the salesperson earn in commissions in terms of X, Y, and Z? So first things first is recognizing that this is exactly the kind of problem where we can plug in our own numbers. Why? Well, again, because I have variables in the question and I have variables in the answer option. So that's the green light for me to plug in my own numbers. But I need to be careful because this problem, unlike the last one, has a restriction. It tells me that whatever I pick for Z must be greater than X plus Y, whatever I pick for X plus whatever I pick for Y. So as long as I abide by that condition, I'm good to go. And I don't know what numbers you picked, but I went ahead and chose these numbers. X is 1,000, so he earns a 2.5% commission on the first $1,000 of sales. There it is. A 5% commission on the following $5,000 of sales. We'll write that in. And a 7% commission on all sales thereafter. If the salesperson made a total of $10,000 in sales, how much in commissions did the salesperson earn? Now, the key to solving this kind of problem is not to get hung up on all of the algebra in it, right? The more you worry about all the X's and Y's floating around, the less you pay attention to the real simplicity of this problem. So let's actually plug these numbers in and solve it for our target answer. Here it goes. So I'm going to earn a 2.5% commission on the first $1,000 of sales. How do I calculate that? Well, it's 0.025 times 1,000. And then I'm going to earn a $5,000 commission on the next $5,000 of sales. Now here's the tricky part. I'm going to earn a $7,000 commission on all sales thereafter. That doesn't mean I earn a $7,000 commission on 10,000. 10,000 was the total number of sales that I made. How many sales did I make after I sold 1,000 and 5,000, so 6,000? Well, to get to 10,000, I sold 4,000, right? I sold 1,000, I sold another 5,000 for a total of 6,000, and then I need to make 10,000, so that's another 4,000. So it's going to be 7% of 4,000. If you mess that up, that will do you in. Okay, so what are these actual numbers? 25% of 1,000, or excuse me, 2.5% of 1,000 is $25. 5% of 5,000 is $250. And 7% of 4,000 is $280. And if I add these all together, I get $555. And that is my target answer. And now that I have my target answer, what do I need to do? Well, I need to plug the numbers that I chose into the answer options and see which one gives me my target answer. Now, A is a very, very tempting answer option, especially if you don't use this picking number trick. I mean, look, it matches the commission structure pretty closely. I got 2.5%. I got 5%, and I got 7%. But the problem is, this is 7% of the whole amount of sales, right? And we're going to see why this doesn't work when we plug in the numbers. Let's plug in 1,000. So 1,000 times 2.5%, we saw already, was 25. We plug in 5,000. 5% of that is 250. And then we plug in 10,000, we get 700. This 700 plus 250 plus 25 does not equal our target answer, and so it's not correct. The correct answer is actually B. And we plug in our numbers, we see that, right? I got 7% of 10,000, so that's 700, right? Minus 20% of 5,000, that's 100. Minus 4.5% of 1,000, 45. Sure enough, 700 minus 100 minus 45 equals 555. Now, you could have solved this problem algebraically, and I encourage you to do that. But if you had, it would take a while, and you'd still end up at B. So, when you see variables in the question and variables in the answer, and you don't want to do the algebra, you can use this method.